afternoon, everyone. My name is Jason Schaffenbuhl, Assistant Vice President, Loss Control with Argent. Here to provide the webinar for you today on machine guarding. Machine guarding is sadly a simple but really difficult topic, and the issue is that it's simple in terms of what you need to guard and what the guarding expectations are. It's difficult from the extent of getting things guarded in a manner that still makes the equipment usable. I'm not saying that guarding hampers productivity, efficiency, quality. There was an informal study at John Deere done in the 1970s. John Deere realized that if they properly guarded their equipment and their facilities, they could produce more product, higher productivity, and higher quality with proper machine guarding. And so John Deere and other organizations realized that you had to be creative in what you did in terms of machine guarding to be successful in coming up with good guards that employees could utilize to protect themselves but also produce quality product. Today we're going to be talking about key parts of machines, just real generic, common machine hazards, OSHA's general guarding requirements, the general guarding principles, and then we'll get into a few machine-specific guarding requirements, things that OSHA specifically has in their regulations, and we'll talk about conveyors at the end. For those of you that don't want to participate in the conveyor piece, you can stop at that point in time. But conveyors are unique. They're machines, but because of their nuances, there's some specific requirements. Just the key parts of the machine. You have the point of operation. That's the point where work is being done. It's the interface between the drill bit and the material being drilled. It's the point at which the shear cuts the metal. You have the power transmission device. That's what's transmitting energy to the part of the machine. So it could be a shaft, flywheel, pulleys, belts, connecting rods, couplings, all the different things that may make that up. There's other moving parts, feed mechanisms, auxiliary parts of the machine, things that are moving as part of the machine, but it's just ancillary to the machine, but they can also pose a hazard. And then there's the operator controls. And while you don't have to guard operator controls can be a form of guarding, but we need to make sure they're properly installed. And it's always amazing to me how many times I see guards or operational controls that are improperly installed that create a hazard. And so we'll talk about that. So where do hazards occur? Basically, the first three parts of the machine are where the hazards occur, and those are those that need to be guarded. So the point of operation, the power transmission apparatus, and those other moving parts. And that leads us to the general requirements. In general, you want to make sure a machine is protected in such a manner that it prevents entry of the hands or fingers into the point of operation by reaching through, over, around, or under the guard. This one's problematic because a lot of people think, oh, I just guarded the face of it, and I'll show you a belt guard here in a little bit. But if you can reach around it, under it, and still get into the point of operation, the power transmission apparatus, or another piece of equipment that's moving that can cause harm, then it's not properly guarded. More and more people are looking at robotic cells, and they put a fence around the robotic cell, and the question is, well, how low to the floor should the fence go? And it's generally accepted that the fence should go within 6 inches to within 6 inches of the floor. More than 6 inches, you can have people try to reach under. You can still get a broom under it, 6 inches, those types of things. How high should it go? Well, if it doesn't go high enough, then people can crawl over it, they can reach over it, and so typically it's a minimum of 6 inches from the floor to 60 inches high is typically. It just depends on what standard you're looking at. OSHA doesn't have a particular standard, but there's a number of ANSI standards and international machine guarding standards that are in that 6 inches to 60 inches. I see that one person has their hand raised. If you have a question, please feel free to chat me. I'll try to answer those as we go if I can keep up with them, or answer them at the end during the question and answer section. The guards for OSHA, the United States, guards should conform, or the openings in guards can conform to the maximum permissible openings in Table 010, and we'll talk about that in a little bit. And again, the guards shouldn't create their own hazards. They shouldn't create pinch points between the guard and any moving machine parts. And I'll give you a video example of that as well. The fasteners utilized on machine guards should not be readily removable by the operator. We want to make sure it's challenging to remove that guard, but if the guard can be removed, then the guard should be interlocked to prevent the machine from operating with the guard removed. Nobody really defines what, readily removable fastener isn't. Used to be, you'd say hex, or you'd say a security screw, but those have also become quite common. You can go to virtually any hardware store and get a security screwdriver. And so you need to think about what's in your operation, what's available. If employees have a whole tool chest in front of them, then you're going to be looking at a more complex fastener. But if they don't have access to the removal tools for some of these specialty fasteners, then that may be appropriate. The guard should facilitate inspection. You need a clear plexiglass panel in it so they can look through it and view operation and view inspection. Should it be expanded metal so it doesn't collect debris on it? Consideration needs to be given to the construction of the guard to make sure it's strong enough. It needs to be given consideration to the usability of the guard. Can they see into the machine if they need to? And it needs to it should allow any routine inspection or visibility, as I indicated. As I talked about, the hazardous motions that are present in the machine. So you're going to have rotating motion, transversing motion, and reciprocating motion. Rotating motion, even if it's really slow, and I'll have a video here in a second, it can grip the hair, can grip your skin, can grab clothing, and cause potential injury to individuals. And so here on the left we have a coupling with bolts sticking out, so those bolts pose a hazard. And on the right you have a keyway and you have a screw set on that collar. And so all of those create a hazard, and you need to properly guard that. Whether it's a fixed guard or guarding through distance, you'd want to protect employees from that. Towards the end of this presentation I'll talk about shafts sticking out against bearing blocks and when those need to be guarded. You can have nip points. Nip points are any time where you have a point where you can get your hand in it and be crushed, nipped, either because the parts are rotating inwards or there's elements that are moving in such a manner that would cause it to grab or catch a piece of skin or body part or clothing. So here's an example of 4 different nip points. Here we have in-running nip points from intermeshing gears or calendar rolls rolling together on the right-hand side. Here's the nip point created by a moving object and a fixed barrier guard. So here a guard created a bigger hazard. Here we have a transversing element with that gear running on that. Excuse me. And then here we have the point of contact between the belt and the chain and their respective pulleys and sprockets. So all of those need to be guarded so they don't create a hazard to employees. We have reciprocating motion, any back and forth or up and down motion where an employee can get caught between the object and a stationary part or a moving part. And so you need to be careful of those. There's a fair number of these in the workplace, but one of those I see is the big automated presses where the sheet moves and the press body stays in one place. And so sometimes I've seen those presses installed in such a manner where an employee can get between the press table and a wall, and if the sheet were not centered on the table or off the edge of a table, that the employee could get hit by that. So we need to make sure that it's either protected by distance, a guard, some type of safety device, or we have it so that the employee can't get into that location. So we have the hazardous motions, the hazardous actions we need to watch out for and protect individuals from. So we have cutting. Anytime we're doing cutting, especially if it's metal cutting, wood cutting, if you can cut that material, you can cut human skin. And so we're worried about the cutting hazard itself. We're worried about the debris coming off of that as part of that process. So milling machines, drill presses, CNC machines. And here's just 2 examples of cutting operations where you'd want to be protected. You wouldn't want your employee to put their hand in that slot as it's being cut in the top picture. And you don't want an employee to get their hand cut by the interface between the object being milled on that lathe or the chips that are coming off of it. And so these are 2 areas that you need to make sure that are guarded. And guarding an old engine lathe is possible. It's just challenging to do. Punching operations such as a punch press, little rivet machines, those types of things, anything where the material is being crushed and cut, or crushed and cut in the case of a punch, is a concern as well. Again, you get your hand in there, it's going to cause damage. So here we want to make sure we're guarding so employees can't get their fingers or hand between the punch and the object being punched out. Same thing with a shearing operation. We're concerned about the point of operation where the stock is cut by the shear itself. So again, we need to look at guarding. And last but not least is bending, such as in a power press, where you're taking a piece of material and you're pressing that object into a certain shape, whether it's metal, rubber press, plastic, molding operations. Those are all possible. And again, you can imagine the damage that would be done to an employee. So the hazardous operations, the hazardous motions and the hazardous operations all leads to needing to do machine guarding, and that's what the focus of this presentation is on, is the methods of machine guarding. Again, principles of the guarding: we want to prevent contact, make sure the guard's secured, it's protecting the employees from objects falling into the machine, protecting employees from objects flying out of the machine. There should be no new hazards created by the guard, no rough or sharp edges. Make sure that there's no places where the operation of the machine would pose a hazard because of the guard, such as that rotating shaft, that rotating pulley we saw before in the fixed guard. We want to make sure there's no interference with the job that allows the employee to complete the job in a comfortable and efficient manner. And one thing I like to look for is allowing safe lubrication. If you look at a lot of industrial equipment, more and more are moving points of lubrication out to a common place. So you have all your grease zerks at one location that you don't have to go past the guards. You can keep the machine guarded up, secured, and the employee can stand outside of the hazardous areas to do all the lubrication that's necessary, whether that's through automated oilers, extended grease lines, or those types of things. Where this gets really challenging, it's important to realize this, is that the United States is the only industrialized nation where machine guarding is up to the end user. And commercial equipment, machine guarding is up to the end user and not to the manufacturer of the equipment. In all other countries, the manufacturer has to do a risk assessment of some form, identify how and when employees will be interfacing with the machine, whether it's through operation or maintenance or repair and setup, and make sure there's adequate guards in place. That is not the case in the United States. In the United States, it's up to the end user. You, as the employer, has to decide if it's guarded properly, and that creates problems. And so that's where it's really important when you buy equipment, talk to the manufacturer about, what other guards do you sell? I have a picture of a fixed guard, some fixed guards later on that were never initially installed on the equipment. But after, I believe it was after an OSHA citation, the employer went back to the manufacturer and said, look, we just got an OSHA citation. And the manufacturer goes, oh yeah, we sell a whole guarding package for that. We have like 12 guards that go on that piece of equipment. And the employer was really upset that why weren't we offered this? Why was it extra cost? This machine is dangerous. And it's like, look, we don't have to provide it. It's up to you, the end user, to ensure it's properly guarded in the United States. So typical guarding methods. Excuse me. Typically we're looking at guards and devices, and I will show you an example of other methods, but I can't imagine another method that's truly a guard, and you'll see why when I get to that example. The first thing to remember that guards are barriers. Guards prevent access to the dangerous areas. It just prevents us from getting in, or employees from getting into that point of operation. It's not relying upon the employee to behave themselves. It's not relying on the employee to be paying attention. The guard just protects the equipment from the employee getting their hands into it. So there's 4 types of guards that we typically see: a fixed guard, interlocked, adjustable, and self-adjusting. And we'll give you examples of all of those. A fixed guard, that belt guard on the left-hand side, there's a great example of a fixed guard between that drive unit, the motor, and some type of drive device. I'm not sure what that was off the top of my head. It's a permanent structure. It's attached to the machine. It's not adjustable. It's there. It serves its purpose. The only time you need to take the guard off is if you're doing some adjustment or replacement to that belt or chain, assuming it's a belt in this case. And so that's the preferred type of guard. On the left-hand side, we probably have a shaft there that's covered by that, or the right-hand side, we have a shaft there most likely that's covered by that bent piece of yellow metal. I'm not sure that's a great fixed guard because I don't know if I can get my hand in there to grab that shaft. So we have definitely a good guard on the left-hand side because it's guarding on the back side as well. I can't reach my hand around that guard to get my hand in there. The guard on the right might be good, might be able to make it better. Just can't tell from the picture. Here's some fixed guard examples that were a nice try. They just don't quite get the job done. Both of these are some type of pneumatic pumps. Actually, they're both the same type of pump. They're just two different guards that they had fabricated in the same facility. So on the first one, we see that we can have the hazard created by the pulley going around on the fixed guard, the one on the left, I should say, and the interface between the nip point created by the belt and the pulley. And on the second one, we don't have any problem with the belt and the pulley, or the right-hand side, we don't have any problem with the belt and the pulley. But if an employee were to stick their finger in there when that fan is, or when that pulley is probably turning at 1,700 to 3,000 RPM, that can take your finger around real quick, either break the finger or cause it to be lacerated when the finger gets wedged between the pulley and the guard opening. So again, important to keep in mind, are our guards really protecting everything? We've got to make sure we're protecting all sides of that belt and pulley. Here's that saw I was talking about. This is a saw from a truss plant, wood truss plant. So wood goes in on the far side, the opposite side of this picture here, and it's cut by, I'm guessing there's at least 4 saw blades in that particular unit, maybe more. And none of those orange guards came on that saw. I should say the expanded metal orange guards. None of those came on that saw. That those were all added on after an OSHA citation, if I have the right picture. But you can see there that there's a lot of big blades there. Some of those are 24-inch saw blades spinning around. You can easily actually stick your hand inside and make contact with those saw blades. And nobody thought anything of it because there's no reason to stick your hand in there. Put the boards in on one side, they come out cut on the other side. Why should we be worried about this? But yet the manufacturer had nice guards. They just sold them as one heck of an additional option that you could purchase, but they didn't clearly advertise. Interlock guards. Interlock guards are guards on equipment. Could be fixed equipment. Could be a type of fixed guard, but on like a hinge or something, or an opening or a panel. But when you open that interlock guard, it shuts down the equipment or powers down the section of equipment that's hazardous. And when we have really long, complex manufacturing lines, maybe you have a bottling line, so you have where the preformed bottle comes in, you have the blowing machine, you have the conveyors that carry the bottles to the filling line, you have the filling line, you have the capping area, you have the packaging line, that you need to look at the sequencing of when I open this door, what does it shut down? Does it shut down the entire machine, or does it shut down the hazardous operation in the particular area I'm at? The key here is that we want to make sure that you cannot bypass the interlock guards. Just simple mechanical switches that you can hold open or you can put a piece of metal over aren't acceptable. You need to make sure that they're keyed in a manner that you can't simply defeat it with a screwdriver. And we want to make sure they're properly wired in a manner that if we do open it, that does it allow the machine enough time to spin down? There's interlocks that you can get. It's a 2-step interlock, and I forget the technical term for it. But you initiate opening the interlocked guard, but then there's a timer on it, so it won't allow it to open or be fully released until 30 seconds, 45 seconds, so the pump or the motor or whatever the hazard is on the other side of the guard can come to a complete stop, so it no longer creates a hazard. So there's a lot of sophistication that can go into interlock guards. Some of the things when we go into facilities, we look at interlock guards, we look for bypasses, simple contact switches, simple magnetic switches where they've just stuck a washer to the guard into the interlock. So the door never needs to be closed because the magnet's there, or the washer is there bypassing the magnet. There's a lot of CNC machines, especially CNC machines in the last older than 3 to 5 years. I used to have a catalog of all the codes for the primary manufacturers of CNC machines of what the bypass were for the interlocks. That you could go in the program of the machine and you could bypass those doors so the doors could be open while the machine was operating. Is it safe? No. Are there times where a repair technician might need to bypass a guard? Possibly. But should an operator ever have those codes? No. And I love going into manufacturing facilities with a lot of CNC machines and going up to the setup people and the maintenance employees and saying, hey, do you know the bypass codes for this? Oh, yeah, yep, I know them. It's always amazing who knows the bypass codes. And you may have never heard of them yourself. Management may not know about them, but it's amazing that employees can find them and they'll expedite the use of those the software bypasses. The other thing to keep in mind is jog controls. On a lot of equipment, the jog controls allow you to bypass the guards as well. The intention of the jog control is to either operate the piece of equipment at a very, very slow speed or an incremental step-by-step speed. So technically, you hit the button, it jogs a little bit, and so nobody should be exposed to the hazard. However, if the person jogging the equipment isn't the person that has their hand that could put their hand in the machine, this is where we see injuries happen. We see a number of injuries coming from doing setup where one employee is controlling the jog button and another employee is getting their hand crushed. So we need to keep that in mind. Who's all involved in the task? And so it's important to understand how the equipment is set up, operated, maintained, when do the controls function, when do they not function, so people can protect themselves. Or you might have to change the controls to make sure that employees are protected. A bandsaw is the perfect example of an adjustable guard. You need to make sure that the bandsaw has the guard on it, but you have to adjust that guard up and down depending upon the thickness of the material you're cutting. On the right-hand side, that's a pin guard, and so that might be for like feeding a press. And those pins would be adjusted manually depending upon the stock that's run. So today we're going to run a square tube, and so you adjust it to allow the square tube in. Maybe you're running a channel or an angle, and so then you can adjust those the black drop-down pins they're called, for the material. And so you need to make sure that somebody's looking at those. They just don't run those pins up, keep them screwed in place and run everything through it. So there has to be some setup process. You have to take the time when a machine is changing from one part to another part, from one raw material to another. Somebody goes, make sure it's set up properly. Supervisor, the employee, you just need to make sure it's done. OSHA doesn't specifically state who has to do it. However, if it's not done and somebody's injured, you will get a citation. Even though it was the employee's responsibility to check, it's not really going to hold up in most cases from an OSHA citation. So here's, again, those pin guards, adjustable guards. The adjustable guards allow you to, adjust the guard for the product that's running. You decrease the opening to the smallest amount that's possible for the particular stock that's being utilized. Self-adjusting guards. These are guards that allow the guard to adjust to the movement of the stock. Self-adjusting guards are as good as you get on some equipment. You think about a planer on the left-hand side there, and as you're using those two blocks to push that stock through, everything's fine and dandy. But what happens if that stock isn't there and you just slide your hand down that table while the planer's running? Well, your hand operates it like that stock. It opens up the blade cover there, and your hand goes through the planer. Doesn't happen often, but occasionally it does. Table saw guard on the right-hand side, same type of thing. That guard's there to protect against inadvertent operation, but if you were to slide your hand on the bed of that table saw through the blade, it's going to let you do that. The guard doesn't know if your hand's important or if your hand's a piece of wood being cut. And so we'll come back to table saws about the splitter and the kickback devices as well. But all of this comes down to your guard distances. Now, OSHA never really intended for this table to be used for all machine guarding. However, it's the only thing OSHA has. OSHA doesn't have a lot of machine guarding standards, obligations, requirements, however you want to put that. And so they really rely upon this Table 0 from 1910-217. It's Table 010. And it says, look, based upon how far you are from the hazard, that tells us the maximum opening available. So if you have a guard that's half to an inch and a half away from the hazard, maybe it's a punch press, for example, a punch, as we saw, the maximum width of that opening is 1/4 of an inch. So I can't get a fingertip into that opening. Now, if I'm 10 inches away, so I'm in that 7.5 to 12.5 inches away, the biggest that opening can be is 1 1/4 inches. And then if I get 17.5 to 31 inches away, the biggest opening I can have is 2 1/8 inches. So even at most people would say 30 inches away is quite a distance away. You can't have a very big opening to that point of operation, that hazard that's created, and so you need to be aware of that. And there's a number of people sell these gotcha sticks, is what they're affectionately referred to. This one is from Rockford Machine Guarding. If you take Rockford's day-long, 2-day-long machine guarding course, actually it might be 3-day-long machine guarding course, they give you one. Some machine guarding companies will give them away. Otherwise, you can buy them anywhere from $5 to $25. And this one here is based upon the OSHA standard. And the reason I bring this up is OSHA has a standard that's legally enforced in the United States. However, there's also an ANSI table, which was based upon some work that Snook did. And it's, excuse me again, in some areas it's a little more protective, in other areas it's a little more open. But this is what's used in most other countries. It's what's used in the ANSI machine guarding standards, the American National Standards Machine Guarding Standards. And it's also, I believe, what's used in Canada. Or Canada may have their own guard opening clearances. And you can get gotcha sticks that have both the OSHA, the Canadian, and the ANSI ones all together for like $20. At a minimum, I'd say, look, stick with the OSHA one. If you want to pick the, if you have a stick that has both the OSHA and the ANSI on it, pick the one that's more protective or smaller openings, because there is a slight difference in one area on the gotcha stick. But it's important to keep this in mind. If somebody's ever doing a machine guarding review, the first thing they're going to look at is how does the machine operate. The next thing they're going to look at is what guards are in place. And then they're going to look at if they're fixed guards, barrier guards. Are the openings too big in relationship to the hazard that's created in the machine? Devices are not guards, but devices are a thing, I was going to say device, that prevents entry into the point of operation during the operating cycle. So it might be a light curtain, it might be a safety mat. It's something that says, okay, you're here, I can't operate, or then senses that you're far enough away, you're not in the area of operation, and then it allows you to operate. So they're typically of 3 types, but we're seeing more and more with advances in technology. They're either photoelectric, they're radio frequency, which I don't see many of anymore, or they're electromechanical. But they just sense if something has bypassed a plane or is in an area that is unsafe and stops or slows down the equipment from operating. Because I'll show you one that can stop, warn, and slow down. So here's a light curtain on a small press. You can see the video there as the employee puts his hand in, the press stops automatically. Now these types of presence sensing devices are wonderful. They can be very useful. Should they replace fixed guards in all circumstances? Absolutely not. They're expensive. The other thing is we have to be very sensitive to where these presence sensing devices are installed. We have to understand the speed at which somebody can approach the equipment. We have to understand at how fast we can stop the equipment. And we have to understand how quickly the circuitry can tell the machine to stop. And so there's some complex formulas that go into ensuring that you have adequately positioned that presence sensing device so it can sense that somebody's broken that path and that they can't get to that hazardous area. So it's not like you're just going to go buy a light curtain, slap it in place. There needs to be some calculation that goes into understanding how all this works together. And a lot of organizations slap light curtains and other presence sensing devices on equipment, and they have no idea if it works. And then we don't have a means to test it later on, or we're afraid to test it because of how the stopping circuit is wired into the equipment, that it destroys the motor. And so we never know if it works or doesn't work until it doesn't work and somebody has their hand crushed or amputated. But typically these photoelectric devices, such as a light curtain, use light sources, lasers, or LED, and an interruption of the light source stops the machine from functioning. If you noticed in that particular video, it has stopped, that every time he pulled his hand out, then the machine would start to cycle again. OSHA allows that, but they really frown upon it. But there is a section in the OSHA standards on machine guarding that allows the operation of the machine where you're not hitting a reset after you violate a light curtain or a presence sensing device. But you don't see a lot of it because OSHA is pretty strict on how it's enforced. I would hope that as technology improves, OSHA's presence sensing device regulations would actually catch up, but I don't have a lot of hope in that. Here's a video of a SICK brand LiDAR detector. It's a laser detector. SICK is just one of many manufacturers of these types of detectors. I have a lot of experience with them, and I happen to like them for certain applications. But what it does is it sends out an invisible laser beam, and as the employee approaches it, it can be programmed in a very precise pattern as to what it does. So in this case, they programmed it for 3 stages. The yellow would be, it just warns you the light came on, which we missed. When he gets into the orange operation, it sets off, in this case, an audible alarm, and the machine goes to a very slow motion. And we'll see in the 3rd time here when he comes into this area, it's programmed so as he gets closer that it actually stops the equipment from operating, and then he has to go and reset it. Now these laser scanners, LiDAR detectors, LiDAR you've probably heard about in autonomous vehicles. There's an argument between Tesla and all the other manufacturers whether LiDAR should be used or not. But they can be used horizontally or vertically. And as long as they have a line of sight, they can have quite a bit of distance, travel distance outwards for warning areas. And you can configure that pattern. It doesn't have to be a square, rectangle, and you can get really precise in how you control it. The other nice thing is if you're in a heavy industry and you have pressure-sensitive mats and they wear out a lot or they just get driven over by forklifts and destroyed, I found that these SICK scanners work really well, or these laser scanners work really well in those environments because you can drive through it. A forklift's not going to destroy it unless it hits the scanner. I even had robotic vehicles, self-guided vehicles in a facility that we had these SICK scanners on that they watched around the vehicle. I wouldn't imagine putting one of these on a forklift yet because of some technological limitations, but technically you could put this on a forklift, and if the forklift got too close to something on the right or the left, it would stop from operating. However, most forklifts would never be moving since they're driven in confined areas. The SICK scanner can't determine if it's a person or not. It just knows that something entered that area. And it actually has pretty good resolution. Typically, you'd have to look at the standard, but I think down to 2 inches in diameter, maybe even less with the SICK scanner. It's quite good. Here's another type of photoelectric scanner. I don't have a video of it, but it takes a picture. It's using sensing cameras, and it's looking for motion within specific areas. And this is the type of thing that we see in video camera systems, like it motion detects and it turns on. Well, in this case, it's programmed for a specific pattern within the camera, and then it stops the machine. And Pills is one of the companies that has that, and I'm sure there's others now, especially when we're looking at image and optical detection within video streams. It's getting easier and easier to do with today's computers. Radio frequency, I was going to say it's been decades since I saw one of these, but just not too long ago I ran across a piece of equipment that had a radio frequency or capacitance detection on it. On the machine on the left-hand side, you can see all that yellow, and that's the antenna. And so if anything goes in there and breaks the plane of that radio frequency or interferes with the capacitance, the inductive capacitance of that, it's going to shut that machine down. No idea. They must be fairly reliable since OSHA permits them. You just don't see them a lot, so I assume they're temperamental. On the right-hand side is a press that has a radio frequency or capacitance detector, and so it stops the machine from operating. When we get to the table saw later on, I'll talk about saw stop, and it uses inductance instead of capacitance to stop the blade on a table saw. So it's another type of presence sensing device. Electromechanical. These are devices such as contact bars, ropes, or probes that are designed to stop the machine operation. Now, for most of you, probably never worked in a rubber plant. The body bar there is good in theory. It's about practically the only protection you can put on a press or a mill like this. However, you never want to be in a situation where you're hitting that body bar because it probably means your hand's being pulled into that mill. And usually those mills rotate. There's such mass there and the drives don't allow them to be immediately stopped that the bar protects your arm up to the shoulder. So you're going to be pulled in up to the shoulder, you'll amputate your arm. And by the way, those mill rolls are typically heated by steam, and so they're hot, and so your body's being burned while you're stuck in the press. However, in this particular instance, it's about the only effective guarding you can use because of what the employee has to do at the interface of the rubber on that mill roll. You can see on the left-hand side he's cutting the rubber to take a piece of the rubber off that mill roll to start a feed to something. One of the more common ones are drop-down probes. These are probes, and this is a little like riveting machine or a little punch machine or maybe a arc welder, a spot welder, that the welding tips will come down and that probe will drop. And if the probe is kept from going fully down to where the material should be, such as a fingertip is in the way, it'll stop that machine from operating. As long as you're running the same material, the same thickness of material, these can be very reliable, consistently used. It's if you're on a piece of equipment that you're really doing a lot of change out, these get to be a pain to maintain. But I'm sure there's been progress made in these as well. But they're available. They're not terribly expensive as long as the machine can be interfaced to stop that cycle from finishing or going full through. So this couldn't be used on like a clutch press, full revolution clutch press, but it could be used on most hydraulic or pneumatic stamping, punching, riveting, welding operations where you have more precise control over the operation of the machine itself. Restraint devices. This one, in theory, restraint devices are great. They put a strap on your wrist, and the wrist is adjusted such that you can't get your hands in the point of operation. You can get them close, but you can't get them in the point of operation. I, in my life, had never seen a restraint device until about 2 years ago. An employer actually installed a restraint device on a shear, similar to what you see in the illustration on the left. Now, restraint devices in theory are really good, as I said. However, it requires that the employee put the restraints on. It requires that the restraints are adjusted properly. It requires a lot of things that usually never happen, and there's very specific requirements for using a restraint device. But here's just an illustration on the left, some type of shear or brake in the center, and a small like riveting press or something on the right-hand side that all have pullback devices. They're not terribly expensive. Depending on some of them, they're really cheap because it's just a fixed structure overhead with a fixed length restraint. And others, they're a little more complicated because the employee may have to put their hand through the point of operation, then as the machine cycles, it has to pull that restraint back. In theory, really good. In practical application, unless you have a lot of discipline in your organization to make sure they're properly inspected, tested, adjusted, and maintained properly on a very routine basis, we're talking daily, if not more frequently than daily, probably not the best, but in some cases it might be the best solution there is. Safety control devices, not really guards. They're not really intended to protect an employee from operation, from hazard. They're usually something's happening and I need to stop the equipment from operating. So they're quick means for activating, deactivating the machine. Safety trips and e-stops are the most common. Again, they're not true guards, but they are permitted in a few applications. Now, a two-hand control can be as effective as guarding, or maybe a foot control, but we'll talk about that. So here's a rubber mill. This is before they ever put body bars on them that were tied into emergency stops. This goes onto the top, so in this case here, you hope as you're being pulled into it, remember to pull that trip. We see the same type of trip device on big shredders, wood shredders, tree shredders, that as you're being pulled into the shredder, you really hope you're able to pull that bar. So some of the things we look at on these trip devices is what direction do they operate. I've seen on wood shredders, tree shredders, branch shredders, whatever you want to call them, that the safety trip only works if pulled in an outward direction. So if you're standing on the outside of it and you begin to get pulled in, you can yank on it as you're getting pulled in. But once you're past the plane of that rope on the bad side, if you pull on it, it won't do any good. So you have to be really conscious of were these installed and designed properly. Usually it's more of an issue of design. I saw a body bar, safety tripod once on a mill like this that only operated in one direction. And so you have to have that type of thing evaluated and fixed if you noticed it. We see safety tripwires, cables, such as on conveyors, commonly used. You need to make sure that there's an e-stop at each operator's location. Does it have to be the stop button itself? No. Could they have a cable near them that they can pull? Yes, that's acceptable. I'm going to show you, if you wait for the conveyor section, that there's some caveats with this, that in this particular picture here, there's a good probably foot section, maybe 10-inch section that's not protected. And so it's important to realize that. And I'll give you an example that I saw very recently of how a machine had a safety pull cable like this installed, but it was installed in a manner that it wasn't useful to the operator. Two-handed controls. Two-handed controls can be an effective guard. The key here is that we need to make sure that the two-hand controls, the way they're wired into the machine and the machine's operation, require that the employee's hands are on the controls until the hazard is passed. So if this employee can touch both black buttons, and they have to be touched simultaneously or virtually simultaneously, that when they touch them, the machine does its thing and the employee can't release the buttons, the machine continues to cycle, and the employee can get their hand in the point of operation. We'll also have to make sure the buttons are far enough apart. They can't use their thumb and their pinky to push the buttons. Been to some facilities where the employees have created a bar that has pads on both ends that they can cycle the machine by using that bar to push both buttons simultaneously. So in this case here, you see the emergency stop button between them, and the emergency stop button sits farther out. So if they tried to use a bar, we'd hope the bar wasn't designed so it had long enough pads that the bar would hit the emergency stop button first. But occasionally we see two-hand controls put on equipment that two-hand controls initiate motion of the equipment. You can release your hands and the machine will continue to cycle, and the employee can stick their hand in it and get their fingers taken off. That's not appropriate. Now there is such a thing as two-hand trip. Two-hand trip, instead of a two-hand control, two-hand trip is you hit both buttons, the machine does something, but the employees can't get their hands into the point of operation. So we see two-hand trip on presses that may have a fixed guard, where the an adjustable guard, where the adjustable guard drops down into place as they hit the two-hand buttons. And as long as that guard can come fully down into place, then the employee can release their hands, and the machine cycles forever, a set number of times. Machine stops, the guard opens back up, then the employee does whatever they need to do, and then again they have to push the two-hand controls. The guard comes down to protect the employee from the point of operation. They can do their thing then because they can't get into the guard. So it's a combination. We have two-hand trip to initiate a guard, then the guard's in place to allow the machine to cycle. Very common application of two-hand trips. Location and distance is effective machine safeguarding. I should say can be effective machine safeguarding. What we need to do is just keep the employee far enough away from the machine that they cannot access the hazardous or dangerous points of operation or the hazard that's present in the machine. Typically, we put it high enough up they can't get to it. We put it against the wall. We put it out of high traffic areas. But it's at a place where people can't get to it. Now, foot controls are always like the panacea of people when it comes to distance. I'll put this foot control in so they can't get to it. But what we see is the foot control is not anchored. The foot control gets right up to the machine. They put their hand in the brake, for example. They step on the foot control and they take their fingertips off. If you're using a foot control as a guarding mechanism, that foot control has to be anchored to the floor at such a distance away that the employee can't get their hands in the point of operation. Here's a picture of a huge press. The employees aren't running the press in the picture, but you can see the two-hand control and the foot control are located so far away, and assuming this is operated by one person, but they're located so far away that the employee can't physically be close to the press while it's operating. That's the other thing we need to keep in mind. There's some presses that are operated by one person. Sometimes they're operated by two people. And so typically we'll have two sets of two-hand controls. Both employees have to have their hands on the two-hand controls within a set period of time to cycle the machine. And then there's a key switch to select between one and two-hand controls. So what type of discipline, what type of process, policy, procedure, whatever you want to call it, does your organization have to ensure that we're not using one set of controls when there's two people operating the machine? So distance is great, but we have to make sure we have a way to keep people at that distance. You know, do we just have a chain up? I'm sorry, people go under, over, around chains all the time. Do we have it in a locked room? Great. How do we make sure we haven't locked an employee in the room when the machine cycles? So a lot of things to give consideration to with machine guarding. So again, machine guarding in theory, really easy. And for application, it's tough to think about all the ways that machine guards can be defeated. The last one here isn't really a machine guarding method. However, sometimes it can be used in, I never want to say in place of a machine guard, to supplement a machine guard. And so, a lot of these are miscellaneous aids such as feeding stock into a feeding mechanism. You would never want to say, look, we don't need to guard. You can't say we're not going to guard a press because we're going to give the employees tongs and they'll just reach in with their tongs. But what it can do is we have a press that's guarded, the guard comes up, and we still don't want the employee to put their hand in that press because what happens if there's some type of failure and the die comes down? We don't want it to crush their hands, so we'd use a malleable tool such as some of those aluminum duckbill pliers. Maybe we use a suction cup or a magnet, but it just keeps the employee's hands out of the point of operation, even when the point of operation should be relatively safe. But we know machines fail, things happen, bad things happen to good people, and so we might want to provide a miscellaneous aid. Now I'm going to get into OSHA's specific guarding requirements for specific pieces of equipment. Fans, one of the first ones OSHA ever came out with, that smallest dimension has to be less than or equal to 1/2 inch. You can go buy a wonderful little 1/2 inch measuring device like that or make one yourself to go around and test fans. As long as that fan is less than, I want to say 7.5 feet from the ground, but it could be 7. But be aware that you don't want to have a fan with big openings that's near the top of a staircase and you forget about people reaching out from the staircase and touching the fan because, yes, we've seen that happen too. Another machine guarding kind of thing, machine guarding-esque, I would say, is the anchoring of fixed machinery. If you have equipment that's designed to be anchored, and usually that's evident by holes in the base to put anchors through, OSHA says that must be anchored. So things such as pedestal grinders, drill presses, other types of machinery that has holes in the base, that's designed to be anchored. And if OSHA were to ever come through and be really cantankerous, they'd give you a citation if you don't have it anchored to the floor. Typically what happens is you don't have a cantankerous OSHA inspector, but you have an employee that's seriously injured when a big drill press falls over on them because they were standing on it to change out a light bulb. And OSHA comes in and says, wow, why did this employee get injured? Well, they were standing on the drill press, which they shouldn't have done. And then OSHA says, oh, look, the drill press isn't anchored. And it was supposed to be because you see the manufacturer provided anchor holes. That will get you a citation, and I can provide you with a real-life example of that happening. Or I did provide you with a real-life example of that happening. Any type of grinders, bench grinders specifically, we need to look at those appropriate guarding. You need to make sure that there's a spindle guard in most circumstances, 99.9% of the time. That tongue tool rest needs to be within 1/8 inch of the stone in red, and the tongue guard in blue needs to be within 1/4 inch of the stone. And the tongue guard's just there to prevent sparks from flying over the top, and if the stone were to shatter, from pieces of that stone coming back towards you. The eye shield is optional, however the employee should be wearing eye protection or face protection. It just depends on your particular organization. There's other type of abrasive wheel guarding requirements. Oh, take a step back. Not specifically machine guarding, but often overlooked, is when you're changing out a grinding stone on a grinder, you need to make sure that you're doing a ring test for that on that stone before you mount it. Stones can get damaged in transit, they can get damaged in storage, they can get damaged on their way out to the grinder, and so you just do a ring test. You try to suspend the stone through the spindle hole, whether you do that through a string or something, or I've seen people suspend it off like a screwdriver shaft. You tap that stone lightly with a non-metallic instrument, such as a screwdriver or wooden mallet, and you listen for it. And if it sounds dead, or if it makes a different sound as you tap around the edge of it, you're going to take that out and not use it because it's most likely it's cracked. And you also want to check to make sure that spindle speed isn't greater than the maximum speed of the wheel. So typically, depending on the type of stone, here they have a small stone suspended by the hole through a small pin or finger. You're going to tap it 4 different places. On a bigger stone, you'd also tap it in every 45 degrees as you'd roll that stone across the floor. In that case, it's a stone or wheel so big that you can't suspend it because you just can't heft it. It's so large. But it is amazing. A fair number of stones will fail a ring test, and you don't want to use it because they can fly apart. Drill presses, often overlooked. Here's an old, I'm going to assume that's an old Delta drill press. It might not be, or an old Rockwell drill press. They've added a lot of fancy controls to it, a magnetic starter, magnetic controls, emergency stop button, looks like a green run light, and they have a chuck guard. Depending upon OSHA's fickleness on any particular year, they either go crazy about these or they overlook them. I can guarantee if you ever have an injury involving a drill press and OSHA comes in and do an inspection and it's not guarded, they're going to give you a citation. That's a guarantee. If OSHA is just coming through your facility and doing a walkthrough and they don't see the drill being used, you got like 50-50 odds that give you a citation for it. Are those guards wonderful? No. They're terrible to use. As a person that uses a drill press, they're atrocious. If I could design a better one, I would. It's kind of like a mousetrap. Build a better mousetrap, the world will beat a path to your door. I think a drill press chuck guard might be in the same category. There's just really not a good way to do it. But you need to take a look at it. What do you have? What's reasonable in your facility? What's the minimum you should do? Radial arm saws. OSHA has some specific requirements on radial arm saws. Blade needs to be guarded. See a lot of radial arm saws where the guards have been removed. And just in the upper picture there, that black adjustable guard is an acceptable guard. It's just to keep you from contacting the teeth from the side. You need to make sure that that head returns back to the home position after it's been utilized. You want to make sure those springs are adjusted in a manner that they don't slam that head back because that creates its own hazards. And then when ripping, you want to make sure that there's an anti-kickback device required. And a lot of times, radial arm saws are used for ripping, and rarely do I see the anti-kickback devices installed. Usually see them removed and forgotten 20 years ago. Table saws. No matter the type of table saw, you need to make sure it has a blade guard. SawStop is unique in the fact that they use a sensor that if your skin, or in all the videos they use, a hot dog comes in contact with that blade stops now. And you might get just a little nick, but it's not going to cause a lot of damage. You probably won't even need stitches. It destroys the blade because it shoots an aluminum block into that blade immediately upon sensing your skin. However, it prevents injury, and SawStop actually sells the replacement cartridges, not too bad of a price. But here we see we have a blade guard, we have a spreader at the back end, and then we have those kickback fingers. There you see one side here, the black fingers that drop down, so that as the board's going through, that blade's rotating, the top of that blade's rotating towards you. If something gets bound up in that board, those kickback fingers will engage to keep that board from kicking back at you and causing serious injury, which is what happens with objects kicked back from table saws. I'm not advertising SawStop saws. Nobody, when SawStop came out with that technology, wanted to license it, so SawStop had to go out and create their own table saws. They have little contractor saws, they have nice cabinet saws, various prices. Other companies now are trying to come up with methods to protect employees in not so similar manner, not to violate the copyright or the patent on the SawStop. However, SawStop, no matter how you feel about this, right, wrong, or indifferent, has been doing more and more to legislate that there needs to be an emergency stopping device on table saws to prevent injury. And since they're the only ones that have such a device at this time, it's somewhat self-serving. However, I do admit it's a great device. It's a very safe device. You'll see that most schools, K through 12 schools that have shop programs, still have gone to this only because their insurance carriers won't insure them from a liability perspective until they've put this type of device in, or this type of saw in. So it's out there, it's available, and if you're buying a good cabinet saw, it's not a lot price-wise different. Band saws need to be guarded. Band saws, however, have a manual blade adjustment. You take that orange blade on orange upper blade guard there, and you adjust it up and down. The intent is that you need to adjust that guard down so it's low enough to protect the employee from getting cut by the blade, but high enough that you can put the stock through. OSHA doesn't say how high that guard needs to be. But basically, I can tell you if an employee gets cut on a bandsaw, OSHA is going to say you didn't have the blade high enough, the blade guard low enough, excuse me. But there's times where an employee puts their finger on the back side of the material being cut, and they just cut the tip off, and the blade guard wouldn't have stopped it because their hand was, like on a 3/4 inch piece of board, and their hand was just right there at the back side of that board. So bandsaws are inherently easy to guard, but tough to have the guard adjusted properly, and impossible to eliminate 100% of the potential for having an injury unless you can automate it so that nobody's ever feeding the blade, that you have a automated feeder of some type, which not too common on bandsaws. I really wished I had the video that worked for this, but it didn't when it converted to the webinar. But a jump saw is a special type of saw. On the left-hand side, you see that yellow hood there. That's guarding the top side of that. There will be a bar that comes down to support that 2x4, and the saw blade will actually come up through that table at a very high rate of speed. And you can see the slot there for the saw blade. And you can see where the employee's hands are. His hands are on a two-hand control in that particular case. Is it guarded as well as I'd like? No, because I could imagine a situation where that employee can get his fingertips up on that slot and cut the tips of his fingers while his thumb is operating the two-hand control. But compared to some jump saws that are foot-operated, this is pretty good, because you can imagine on a foot-operated jump saw, you're there holding the piece of wood, or the stop comes down and you put your hand in that slot and it comes up and cuts it off. On the right-hand side is an automated jump saw where it's well guarded, even though the one guard is down right now, discharge guard is down right now. I think the distance is still enough to protect it. I would never use a jump saw for small pieces of wood, because your hand has to be so close to that saw blade, and that saw blade just comes flying up, cuts the wood, and drops right back down to the table. Happens so fast, all you know is your finger came off. Shaft ends, as I was talking about earlier. Shaft ends cannot project out more than 1/2 the diameter shaft, or if they do, you need to make sure it's guarded. You put a non-rotating cap or a safety sleeve on it. And you should always fill or cover any unused keyways that are exposed, even if it does extend out less than 1/2 the diameter of the shaft. But very common for OSHA to give citations for this. It's right in the regulations, 1910-219C4, that we cannot have that shaft stick out more than 1/2 the diameter from that bearing block. And then you still need to make sure it's safe, that the keyway is filled in so it doesn't create a cutting hazard. Portable grinders should have a guard on them. There are some limited exceptions, but handheld grinders need to have a guard there to keep sparks from flying, primarily is the concern. There's a maximum exposure angle of 180 degrees, so at least half that wheel needs to be guarded. There are some exceptions depending upon what you're grinding, but usually what we see is you're not grinding that thing that the exception applies to all the time. They might be grinding on it 5 minutes, and then the other 55 minutes you're grinding on something where the guard's required. So go get yourself 2 guards. Make sure employees clearly understand you enforce that they're using the proper tool at the right time. Foot pedals, as I talked about earlier, great injury prevention mechanism. We need to make sure they're located far enough away and secured that they can't be slid across the floor to the point of operation or the hazardous area. We also need to make sure that that foot mechanism, that foot pedal, is protected from unintended operation. Usually it's a cover over it. Some require two foot actions to operate. We just don't want somebody accidentally stepping on it, somebody dropping something onto it, and operating that foot pedal while their hand is in the point of operation. Excuse me again. So that covers all the machine guarding requirements. It's important to realize that training is required for machine guards. OSHA doesn't specifically have a lot of training requirements for machine guarding, as they do for presses. However, you're going to find that your manufacturer is required and in the operator's manual, and you can be cited for not doing things that are in the owner's manual or the operator's manual for a piece of equipment. And you'll see that the ANSI standards, and there's hundreds of machine guarding ANSI standards, which is part of the problem. But you'll find almost all of those standards require that you do training on the machine guarding. So you need to train employees on the description, identification of the hazards of the machine so they understand what can hurt them. You need to explain to them how the guards provide protection and the hazards for which they were intended, because as we saw, not all guards can prevent all hazards. If you have a light curtain and something can still come flying out of it, the machine, we need to make sure the employees are aware of the flying hazards. Need to understand how and why to use the guards. Need to understand under what circumstances the guards can be removed and by whom, and what action should be taken if the guard is damaged, missing, or unable to provide adequate protection. And I would guarantee that if I come into your facility after a machine guarding accident, assuming the machine had been properly guarded before, you wouldn't be able to provide me with training records that do all these things that are documented appropriately. And this is why employers get hit with citations, even when they have machines guarded. It's because The unavoidable employee misconduct defense is extremely hard to use when it comes to OSHA. Not impossible, just hard. And not doing training is going to be one of the key tenets of that. So this is the end of the standard presentation. The next 8-10 slides I have are specifically related to conveyors. Conveyors, and I'm using the 2006 ANSI B20.1 standard, the conveyor guarding standard. I'm positive it's been updated since then, except ANSI standards are a little expensive, and I don't buy them all the time. But the 2006 standard would be a good reference at a minimum because, again, it's pretty basic. But it starts out by saying guarding is required whenever it's necessary to protect personnel from the hazards that are created by the conveyor. And so it talks about having, it's going to talk about all the requirements, which we'll go through a number of those. So it says whenever a conveyor passes over a walkway, so if you have employees walking under a conveyor, it's considered guarded by location if all the moving parts are at least 8 feet above the floor or walking surface. So here they've gone above and beyond the minimum here and said instead of saying 7 like OSHA does in most cases, they say 8 because they realize people are taller. Put your hand up, you don't want to caught in a piece of equipment. They say although overhead conveyors may be guarded by location, you still may need to prevent spill guards, pan guards, or the equivalent if material can fall off the conveyor and endanger personnel. So if something can fall off because it's packed poorly, if there's jam-ups, you need to put pans, netting, something to keep those objects from hitting an employee. The standard also says that if you have nip and shear points that you need to make sure those are guarded. So you can see on the left-hand side, that's a slat conveyor. Those are either metal or plastic slats, and as those slats come around that conveyor drum, they get really tight. In some cases, there may be no clearance. In other cases, it might be like 1/8 of an inch or 1/4 inch that you still don't want to get your finger caught in. And so there needs to be some type of guarding there at that end, such as a cover over that end, that allows those slats to come together before employees can be exposed to that. And then on the right-hand side, we have the conveyor going around that drum there, that conveyor belt going around that drum, and we need to make sure we have that nip point guarded there. And typically, again, we're going to put an end over that conveyor to stop that from happening so we can't get that or hand in there. We're going to put a side on it and some type of edge on it so we can't reach that nip point from the top side of the conveyor belt. Belt conveyors typically are going to have the nip and shear points, or typically it says the standard says they shall be guarded, the nip and shear points shall be guarded, and then they list the places where they need to be guarded. So at terminals, drives, take-ups, pulleys, snub rollers. Snub rollers where belt changes direction, as I'm going to talk about next, anywhere where belts wrap around pulleys at the discharge end of a conveyor or a belt conveyor, wherever there's transfers or deflectors, and any take-up point. So if employees can get access to these, you need to make sure it's guarded so they can't get their hand in that point of operation, that point of contact. Where we have a belt changing a direction, and here on the upper left-hand picture, where that employee, that individual has their hand, that belt is coming from the left to the right, going around the drum and returning back to the left. And typically what we see is some type of fixed roller there. And if an employee gets their hand caught between that belt conveyor and that fixed roller, it just burns it down, the skin down, until you get to the bone. And so what you need to have is either a pop-out, you should have a pop-out roller there. What happens is that pop-out roller sits in a trough, and that as that force gets hit against it, going from left to right, in the right-hand picture, you see it goes from the lower position to the upper position. It's just held in there by gravity. Pop-out rollers, though, are a problem. If you have light product or it's a light conveyor and heavy product, as that box or object comes bouncing down that belt conveyor, they can cause those pop-out rollers to bounce out. But you need to have a pop-out roller there or some type of safety device there to prevent employees from getting their hands between that belt and that conveyor. Sometimes we see people put really, like a steel plate there, but then we're worried about that pinch point caused between the edge of the conveyor and the pinch plate. So a pop-out roller is typically the most effective. Conveyor starting. Basically, this says you can't start a conveyor without some type of warning, alert, signal. And this is why if you've ever been at an airport and they shut down the luggage conveyor before it starts back up, you get a yellow light and a horn or a buzzer that goes off. Because we want to make sure that the warning device is actuated enough time before the conveyor starts to warn people that hazardous action is going to be occurring. Emergency stops need to be provided. The key here is that any remotely or automatically controlled conveyors where there's operator stations need to have an emergency stop. Specifically where the operator station is not manned or the employee is beyond voice or visual contact with the drive areas where somebody would be standing to operate the equipment. So basically, anytime you have an employee interfacing with a conveyor system, they need to have access to an emergency stop. It could be a stop, it could be emergency rope that we'll talk about here in a little bit. And you need to make sure that when we trip that, that the employee, it has to be reset at the point where it was tripped. We can't reset it at a control panel that's nowhere near the point where it was tripped at. And that's what that slide says. Conveyors require training. Only trained operators shall be permitted to operate a conveyor. The only conveyor this does not apply to are checkout counters and luggage conveyors for the general public. We shouldn't have to train those people on how to use those because the conveyors should be so inherently safe. But any other conveyor requires training. So if you have a conveyor in your facility and you haven't done training, you're in violation of an ANSI standard, a standard which OSHA would cite you with if you were to ever have an injury related to that. Need to make sure whether there's stopping and starting devices that they're free and ready access. There's nothing stop, in front of the electrical panel, the controls. Make sure that no people ride on conveyors unless it was specifically designed for that purpose. Need to make sure people are aware of the operation of stopping, the location operation of stopping devices. Make sure you're conducting the routine inspections, performing corrective maintenance measures as required by the manufacturer, and make sure that the employees are aware of any personal hazards that they can bring, such as long hair, loose clothing, and jewelry that can be caught in the conveyor. So here's the typical emergency rope. Very common type here. I think this might be a diagram from SICK. They make emergency ropes like this as well. On the left-hand side, we have the pull device, and it's under constant tension. So if it gets too loose or it's pulled on, it's going to trip that device. There's probably an emergency stop device on that controller. A lot of them have them, some don't. The key here is, though, is between that first eyelet and the controller on the right-hand side, that's an unprotected area. So I was on a machine one time, brand new installation. The employee operator station was there. They had that controller next to basically where the employee's thigh was. And then they had an eyelet. And I asked the people doing the setup for the manufacturer, I said, if the employee is in an emergency, what do they do here? And he goes, pulls on the rope. And I said, come here and pull on the rope for me. And he pulled on the rope. And I said, if we were to turn this machine on, would that work? Oh, yeah, that's going to trip. I said, let's try it. Well, the smaller that distance is between the first eyelet and that controller, the harder it is. You just can't get enough deflection in that cable to cause it to trip. So after he showed that he couldn't trip his emergency stop device, I made him change the whole wiring of it. I made him move it to the other end, and so that the employees could reach it and have actuation of it, or I told him he could go get a new controller and put with an emergency stop button on it. I really didn't care which. But from my perspective, it was not acceptable to have an emergency device that the operator couldn't utilize while they were standing at the operator station. And then you can see some other detail there about keeping it spring protected. And again, on that spring end, it wouldn't operate either. And then you look at no more than 10 feet between your eyelets, recognizing that it may or may not work if you're pulling within 1 to 2 inches of the eyelet. And the actuation force should be 5 to 10 pounds, should be able to result in 3 to 6 inches of deflection, and that should easily trip the actuating device. That is the end of an hour and 10-minute presentation on machine guarding and a little bit on emergency stopping devices. I appreciate your listening to this today. If you have any questions, you can chat them in. You can send me an email or give me a call, and I'll do my best. I just got a chat here about how can I get a copy of this presentation. If that individual, earlier today at 10:30, if you were registered for it, you would have gotten an email that had a link to the handouts. If not, send me an email at my email address there, and I will send you a copy of the handouts for today's presentation. Your Argent Loss Control representative, for those of you that are insured by Argent, can assist you with machine guarding. We don't like to do machine guarding assessments because there's a lot of liability in it, but we can talk to you about what's appropriate, what might be appropriate. If you need a real thorough machine guarding assessment, Rockford Machine Guarding out of Rockford, Illinois, and Evergreen out of Minnesota someplace in the Midwest are two, actually in the United States, they're two of the biggest machine guarding companies. They do a lot of machine guarding assessments. They sell machine guarding equipment, and in a lot of cases they can help you interface it, especially with older equipment. And so they're available. If you have general machine guarding questions, sometimes you can just take pictures and send those pictures to myself or your loss control rep, and we can do our best to help you through it, explain to you what concerns we may have or where there may be exposures you haven't considered. But I have no other chat questions at this point in time. Again, feel free to send me an email, give me a call, or you can talk to your Argent Loss Control representative. They'd be more than happy to assist you. Seeing that there are no one's chatted me any questions, take care.